All right, so today we're going to be talking about comparing internal rates of return. And it's an illustration. Are you ready to submit that?
Yeah, I just need to write the numbers because I don't have the numbers on.
It's due right now. You have to just put it in the stack. It's time to begin the class. All right, so today we're going to be talking about internal rate of return and why you can't actually compare them. And just looking into the future, your next homework assignment will be due a week from today, and I'll bring that to class on Tuesday. On Tuesday, we're going to be back in the computer lab again. So we're just here temporarily. All right? I'm also going to give you a copy of the project description today. We'll spend. I posted it online, so maybe some of you have seen it already. Any questions in the back? Any questions? Okay, well, we'll discuss the project for like the second half of class. So let's not do that now. All right. All right. So internal rate of return is a way of analyzing the cash flow diagram and trying to find out what the yield is based on the cash flow diagram. Anybody remind me what is the big assumption with internal rate of return? Yeah. All right, so the earnings can be reinvested into the same project or into a project that yields the same amount. And so what's an example of a project where that might be valid? A savings account, because the bank will allow you to take your earnings and leave it in the account. And then those earnings will continue to accumulate interest at the same interest rate that the original amount you put in. And so a bank account is a good example of something where the internal rate of return is okay. There's lots of projects, though, where that's not the case. But today we're just going to be illustrating the other thing that I mentioned to you, that the two warnings that I gave you was warning number one, you shouldn't use the internal rate of return if the earnings can't be reinvested. And the other warning I gave you is don't compare internal rate of return of two separate projects because it can give you the wrong idea. What you are supposed to do with the internal rate of return is compare that rate to the MAR. And then that will tell you yes or no for a single project. So today we're going to begin a chapter in the book where we're looking at multiple projects. And today's illustration is why you can't use the internal rate of return to compare multiple projects. So let's begin with just sort of a logical analysis, and that is, if you run a business, you want the most profit. Who would agree with that? Raise your hand. Some people don't agree with it. Maybe some people don't like rhetorical questions. That's fine. So let's accept just at the beginning that any company wants to maximize profit. Now, of course, there are other considerations. We have to consider the environment, society, law. You know, the most profit is selling drugs, right? But that's dangerous, illegal, unethical. So maybe we'd want to put a big asterisk next to that and say that the most profit, as long as we're comparing alternatives that have the same environmental impact, have the same social impact, the same legality, and so on. All right? So we want to maximize profits, but what we're going to see is that sometimes the project with the highest rate of return in terms of most profit isn't the one with the highest internal rate of return. So let's take a look at that. You have in front of you a very bad copy of in-class exercise number 1. I mentioned in my message that the toner was running out, and you can see that firsthand in this in-class exercise here. Let me bring up the numbers on the PDF so it's easier to see. I'm going to start by calculating the internal rate of return. Since we're not in the computer classroom, you can't do Part A on your own very easily. You could calculate the internal rate of return manually. How would you calculate the internal rate of return manually? Interpolation, right. So remember, internal rate of return, the definition of it is what? When we have a cash flow diagram that looks like this, we've got some initial investment in the present, We've got some revenues as an annual series. what is the internal rate of return? It's the interest rate that will what? Okay, so he says that will make the interest rate that will make the future values equal to the present values. And that's essentially correct. What we're looking for is the inflows and the outflows to be equal to 0 at the present. So the internal rate of return is the one that puts things into balance. And so how could you solve for that without the computer? Well, take a guess value. Take 5%. Discount this annual series to year 0 at 5% and see, is it 50,000? Is it too high? Is it too low? So try 6%. So you could try lots of different percentages until you would find the inflows and the outflows are equal to each other. That's how you do the internal rate of return if I wasn't going to do it on Excel. But since I want to save some time for our discussion of the project, let's do it the easy way. Fire up Excel, and I'll put this cash flow diagram into Excel so that we can see which one has the highest internal rate of return. Project A, Project B. All right, so we have 10 years during this project. Project A requires an investment of $50,000, and then it's $9,000 each year in revenue. Project B requires an investment, 85. You've got good eyes. 85,000, and then what's our revenue? How much? 14,000. All right. There's two different ways we've talked about to do the internal rate of return on the computer. The easiest one equals IRR. And then we just select the amounts. And so when we do this function, it automatically knows the one at the top of the range is year 0, year 1, year 2. So it's looking not only at the amounts, but at the order of the amounts. We don't even have to close that parentheses. That's how smart Excel is I can press enter, even though I'm not going to put that close parentheses there, and it still just makes up the mistake for me. Okay, so 12.41%. So let's do the same function to the next one, and I don't have to type the formula in. All I have to do is just drag that cell sideways, and then it'll apply the formula to the stack of numbers above it. So I'll just drag that to the side. All right. So which project is best according to the internal rate of return? Well, okay, you remember we can't compare. That's good. But let's say we didn't know that rule, that we were just saying, well, it's better to get 12% interest than it is to get 10% interest. So just at first glance, if you didn't know the warning, if you didn't know the rule, you'd say, let's do project A. All right, but then remember from the earlier slide, what I said is our real criteria is we don't want to maximize some hypothetical interest rate. We want to maximize our profit. We want to have the most money we can. And in this project, it says at the beginning, your company has a MAR of 4%, and you can select one of two projects. So 4% is probably how much it costs you to borrow money. You can go to the bank, and they'll give you enough money for one of these two projects, and they're charging 4%. And so you're thinking, well, the bank will loan me money at 4%. I'll take that money, I'll put it in either Project A or Project B. Maybe I should choose Project A because it gives me 12.4%. And that's 8.4% more than it cost me to borrow the money. And then your friend, who is a contrarian, says, well, why don't you choose Project B? Because it has 10.28%. And you're saying, you know 12.4% is better than 10.28%, right? So it becomes confusing. So what I'd like you to do now is just old style, calculate the present worth of each project. The factors are on the back. I've got the 4%. So discount the revenue that's an annual series to the present using the table on the back and find out which Project A or Project B has the highest revenue at the present. Maximize profits. All right, so part C was a short answer. If you must borrow the money at the MAR, okay, so the bank is going to loan you $85,000 at 4%. We found that if, let's do the NPV function here, because I said that the wrong thing to do is don't compare projects by using the MAR, or by using the IRR. That will give you the wrong answer. All right, so the right answer is maximize profit. Okay, so equals NPV at 4% is our interest rate, and we do it only with these values that are in the future, and then I'm going to separately add the amount that's already in the future. Okay, so that should be the answer for the present value of project A, and we'll do the same thing for project B. All right, everybody, when I was walking around, everybody got these numbers. You're pretty good at finding present values and all that now. It's second nature to you. So this tells us, let's do project B. Maximize profit, so do project B. We're borrowing the money from the bank at 4%. What would it mean if this amount, once we had discounted the revenue to the present, what if we got 0? Then what would that mean if our present worth was 0? Okay, you're just covering the costs of your borrowing. You're doing the whole project, and the only thing you're able to do is cover your borrowing costs. That's what it would mean if, when we discount the future revenues to the present and we get 0 present worth. That means the inflows and the outflows are in balance. It means that the revenues in the future are equal to how much it costs to cover the initial investment. But we got a positive present amount, so that means we're taking all of the revenues to the present at 4%, because that, in our mind, represents how much we have to make to pay the bank back for our initial investment plus the interest they're taking. So whatever is above 0 is the profits that we get to keep. It's the present value of the profits we get to keep. So it's the present value of the cash flow, and when it's in 0, we know that it's in equilibrium from our inflow and outflow. That when it's in 0, it means the revenues are equal to the initial investment. When it's above 0, that means the revenues are greater than the initial investment. And so what this represents, this is the profit that we get to keep above the amount of interest and principal repayment that we will be giving, oh, my typing's getting worse, giving the bank. You get the idea. All right, so that's the answer to part C. Any questions? So this is a good illustration. Don't compare projects based on internal rate of return. Because in what we just saw, if you looked at internal rate of return, it would say project A is better. But we know project B is better, because it gives us more profit. We can only do one of the two projects, and if the bank is going to give us the money at the same interest rate, whether it's $85,000 or $50,000, you might as well go with the more expensive project, because the more expensive project is going to give you a greater yield. All right, so that's part 1. Now, today, part 2 of our lecture isn't going to feel very satisfying to you. I just want to introduce the very first concept of where we're headed next. And it's so easy, you're going to think, why did we even bother? It's called an incremental cost, incremental revenue, and incremental salvage value. So say, for instance, that we have 2 different projects as an option. This is a different project here than what we just saw. Project A or Project B. You can see that Project A is more expensive than Project B, and the thing about it is it has a lower annual cost, though. And so maybe that's why it was more expensive to begin with, is that the annual cost, maybe it's more durable, it doesn't need as much maintenance. For whatever reason, the annual costs for item B are lower, and then it has a greater salvage value at the end of the project. When we compare alternatives, what we're going to do is we're going to look at how much more expensive something is. We're going to compare how much less costly is the annual operation and maintenance, what's the difference between the profits from one option to another. And so this column B minus A is an increment. And what we'll do is we're always going to order them in terms of the cheapest option on the left and the most expensive option on the right. And sometimes we'll compare 5 or 6 options. So we're always going to line them up from left to right in terms of increasing cost. So this is the simple part that you're going to roll your eyes at and say, why did we even bother? Part 2 on the back side of the paper is find the incremental cost and the incremental benefit between Project B and Project A. And then what we'll do when we get together in the computer lab on Tuesday is we're going to actually use the numbers that you found to do a new kind of analysis that you've never done before. All right? So, finish part 2. It should take you about 30 seconds. Done? Less than 30 seconds. All right, so the incremental cost, if you have negative 85,000 minus negative 50,000, so that's negative 85,000 plus 50,000. So the incremental cost is 35,000. So we have an extra investment. The number that you would write there is negative 35,000. And then the incremental benefit in years 1 through 10, the revenue, it's an extra 5,000 in revenue. So what we'll do on Tuesday is we're going to say, is it worth spending an extra 35,000 in order to get the incremental revenue? So we're going to analyze the difference between the two projects. And that's one of the foundational principles of this discipline, of the discipline of cost analysis, is compare the differences. Ignore the two parts that are the same and focus only on how are two projects different, because if you're trying to choose between them, it's the differences between them that tell you what the answer should be. All right, so let's talk about the project. Some of you have already seen the project, right? Because I posted it online. Let me give you a paper copy anyways. Let's pull up the schedule. I think it's the last class day, is that right? So you've got plenty of time to work on it. Some might say too much time. When you have a lot of time, it's easy to procrastinate. This is one of the projects, well, this class in general is one of the types of classes that you can actually apply to your life, your personal life. It's hard sometimes to apply fluid mechanics to your personal life, right? Or structural analysis. I mean, it's really good professionally. You're going to use it when you graduate to build buildings, but maybe only once in your, oh, you already have it? Maybe only once in your life would you use structural analysis, maybe if you're building a house or something, but cost analysis and engineering economy, you'll use that a lot. Let me pull up a PDF of the project here. All right, here we go. A cash flow diagram for your life. Everybody's most interested in themselves. That's human nature. That's the most interesting thing that you can ever think about is you, right? So I'm going to, for your project, I thought, what's the most interesting thing that these students could do? And I thought, they can think about themselves. So, but there's a twist to it. You're thinking about the money aspect of your life and looking into the future, because sometimes we have unrealistic expectations. Like, I know people who think they're going to retire when they're 50 years old. And then I say, well, let's look at the cash flow diagram of that. You know, will you have enough money by the time you're 50 years old to retire? And they say, well, when I retire, I want to go on a cruise every year. I want to vacation in Europe. I'll be driving a Bentley. And okay, fine, you can have all of those things, but let's just add up how much that's going to cost, okay? And then how much do you have to earn today? And how much do you have to put into the bank to make it possible to retire at 50 with a Bentley? And then they start to realize, wow, I would have to save 170% of my earnings to make that retirement possible. And it's not possible to save 170% of your earnings. So this is like a reality check. And I think it'll be enjoyable in addition to useful. So a cash flow diagram for your life. There's numbered sections here, and the report that you're going to turn in at the end of the project corresponds to those numbered sections. And let's just look at the schedule to make sure when it's due. Last day of class, right, so Thursday, January 7th. Probably what I will do is in one of the assignments around here, I'm going to ask you to submit a draft. Just show me what you've got so far, just so you have some incentive to do a bit of thinking before January 6th. You already have a question? Yeah. Yeah. Okay. Sure, yes. Yeah, I'd be happy to see how it's going for you. Yep. All right. Here we are. Each one of these sections is numbered because in your final report you should have section 1, income, where you are analyzing the income that you hope to have. It's not enough just to say, I'm going to have an income of 500,000 dirhams per year. You can put assumptions into this project, but they have to be supportable assumptions. And so if you say you're going to make a certain amount, show me in the classified ads, or show me on monster.com, or whatever website has job openings, show me which job you're going to have, and where it says the starting salary is 500,000 dirhams per year. Okay? So it has to be grounded in reality. Each one of these sections, I ask you to do a little bit of research. And by research, I don't mean that you have to go to the library necessarily. Your research can be, a search online, or other things we'll talk about in a moment. So, but part 1 specifically is about income. And what I suggest is you look at a period of 40 years, because maybe you'll graduate when you're 23 years old. And so if you work for 40 years after that, then that means you're retiring at 63 years old. And that would still be a little bit early. A lot of people don't start retiring until they're maybe 67 years old or 70 years old. So let's just say, for purposes of this project, that you will work for 40 years. Standardize it. So look at, number 1, what would be your starting salary after you graduate, but also how your salary can change over time. Because people get cost of living adjustments, which is a raise just to keep pace with inflation. And so even if you don't get promoted, hopefully your company will give you a cost of living adjustment, because the prices are always going up. Prices for fuel, prices for food, and so on, housing. But then there's also promotions. Maybe you'll go from an entry-level engineer to the section head, and then you'll become the manager, and then you'll become the president of the company. All right? So, that's great. Assume that and show me how those assumptions affects your income over time. So remember, the whole project title is a cash flow diagram for your life. So what I want you to do in part 1 is show me on the cash flow diagram, what is your income going to look like? How high should that line be? Maybe it should be very high. You're going to get a promotion, so now your income is higher, and so on. Part 1 is an analysis of income. Part 2 is an analysis of your regular ongoing expenses. And this should be the sort of things I'm saying, housing, food, and so on. Break down how much does it cost to live where you're planning to live. Maybe you'll be staying in the Emirates. Maybe you'll be living somewhere else. So do some research, look up online, either, remember we talked at the beginning of the semester about the CPI, the Consumer Price Index. Many countries have a Consumer Price Index, and sometimes it can vary city by city. And, you know, Abu Dhabi prices we saw were different than living prices in Sharjah. In the same way, in the United States, California is a lot more expensive place to live than North Dakota. All right? So take a look at just the regular, how much it costs to live when you factor all of the regular things. And those will change over time as well because inflation. And so regular expenses are an arrow downward on your cash flow diagram because it's how much money is going out from your wallet. Increase the expenses? Yeah. Yes, you should. Yeah. Because if you assume that in 40 years it's going to cost you 100 dirhams to fill up the fuel tank, the same that it does today, that would probably be a pretty bad assumption. Yeah. It would make things unrealistic. Yeah. So tell me what you assume. Maybe the rent is changing every 3 years. Maybe you buy a house and then after 10 years of payment, no more rent for you. You still have to pay utilities, but you know, if you purchase a house, then after a certain amount of time, then your housing costs go down. So map it all out. Yeah. And in the write-up, in each section, you're telling me what you assumed. Yes? Great, good question. So if you're taking a loan, how would that be reflected? Well, what you could do is you could just have the category be like housing loan. And so that when each month or each year when you pay that, you're paying off both the interest and the principal at the same time. So what I would do is I would say, right now, my monthly budget, $1,100 of it is for the house. And that includes the loan, the taxes, and then the insurance. And so in my cash flow diagram, I just have $1,100 for the next, I think mine is finished in 9 more years. So I would have it on there for 9 years, and then after 9 years, that line goes away. And so that the money can go someplace else. So I think it should just be its own element. The loan for the house, maybe you'll have to take a loan for a car at a certain point. Regular expenses. Right now, maybe you have a car that your parents gave you. It's not going to last forever. You know, are your parents going to give you your next car too? Or are you going to buy that one? The one after that, you know, when you're 40 years old, do your parents still buy your car when you're 40 years old? Hopefully not. All right, so start thinking about how old you're going to be when you're going to start paying for yourself, right? All right, so that's part 2. Extraordinary expenses is the things that aren't regular, like housing, food, mobile. That's predictable, but getting married, that's a big expense all at once, right? I've heard the weddings here are very lavish. So all of a sudden, you're paying a lot of money for the wedding. Or I remember in my life, there was a certain time I wasn't buying diapers, and then there was a certain time when I was for my babies, for the kids. That's very expensive to all of a sudden start buying formula and baby clothes and a stroller. So that's a big extraordinary expense as well. The hospital expenses. My son was born over at American Hospital in Dubai, and they have American prices, I'll tell you that. Very expensive to have a kid over there at American Hospital. I'm saying American Hospital in Dubai, yeah. American Hospital Dubai, yeah. I should have chose someplace else. It was too expensive. Yeah. All right. So think about what kind of things. Someday your kids are going to go to AUS, right? Yeah. Of course not. They're going to get a scholarship and they're going to go somewhere free, right? Yeah. Maybe they'll go to UAEU, who knows? But you have to think, your kids at some point are going to say, I want a car. And so are you going to get them Nissan Tita? Are you going to get them the Bentley? I don't know. You have to be prepared, right? So just Part 3 is thinking about the big ones, the big events that, that you need to be ready for. All right? Part 4 is that retirement. So what's different about the retirement part of the cash flow diagram compared to when you're working? Money's just going out. No money is coming in. So you're drawing on your savings. Now, that maybe it's not strictly true. Maybe you have put money into a pension scheme. Some countries have pensions for their citizens and some don't. Some countries you have to pay into a pension scheme. Some you just get it no matter what. So, make an assumption about where you're going to be living. In the United States, our pension scheme is called Social Security. And my assumption is that that pension scheme will be bankrupt and that I don't get $1 from it. And that's a pretty good assumption. I think a lot of people who are my age assume it's not going to be around by the time that we retire. That all the people who are retired now are taking all the money from it and it will be finished by the time I'm ready. So I'm planning on having to provide for myself. All right? So,
What if I use an investment?
yeah.
That investment, I'm getting money every year even though I'm retired.
Yeah. So you're going to have maybe another column in your spreadsheet that is savings. And here you can see savings. And so not only do I want you to think about how much should you be investing, but also how much is in that big savings account over time. And so what you're going to show is that, over time, here's a graph of your savings. And so here's money and here's time in years. So when you first graduate, maybe you don't have any savings and it's gradually going up and you're ready to retire and then your savings starts going down. What you want, hopefully, there's still some savings left before you get to the end. It's better to, it's morbid, right, to think about your whole life all at once. But they say you should begin with the end in mind. That's one of the 10 habits of highly successful people, is begin every project by thinking about the end of the project. And so think about the end of your life. Do you want to be in debt or do you want to have some left over to give to your children when you go? All right? So back to your question of savings. Yeah, maybe you're not getting any more money coming in, but maybe you're drawing on your savings. And so part of the money balance is looking at what's the savings account doing during this time. All right, so retirement expenses is where you're putting together a budget for retirement. Investment is you have to look at what specific account would you put your money in today. It's not enough just to say, I assume I'm going to make 25% return on my earnings, because that's a pretty high return. If you did find some place that was offering you 25%, chances are it's a very risky investment. And there's a good chance it could just all go away if it's that much of a risk. So, go and look on the website of some banks. Look on the website of some investment companies that are offering bonds. Look in the newspaper under stocks and find out, how much has Apple stock gone up or gone down in the last year? How much has different stocks, what has been the rate of return for different stocks, and maybe they pay dividends as well. So do just a little bit of research on investment and tell me, if you started your investing today, how much of it would go where? Maybe you don't put all of your eggs in one basket, as they say. Maybe you put a little bit in savings, a little bit in bonds, and a little bit in stocks. Well, figure out that balance. We're out of time, so I'll just point out that I'd like you to put all of these, the written assumptions to explain it is going to be in a report, but you're also going to prepare a spreadsheet so that you can easily calculate the time value of things. And so there should be a column in the spreadsheet that discusses your savings account. Now, there's not a single right answer. Everyone's going to have a different spreadsheet. At least I hope so. If you have the same spreadsheet as someone else, then that's going to be a problem, right? Okay. Everyone's spreadsheet should be different. Maybe you want to have a very quiet, simple life where you don't need a lot of income and so that there's not too much stress of trying to make it. That's great. Maybe you want to live in an enormous house with many cars and you want to work from 6 a.m. until midnight every day to pay for it all. And that's fine too. It's your choice. But this whole project is basically just about trying to match up your expectations with how much it costs and whether or not it's a realistic assumption based on the research that you've done. So I'll ask you, please read this between now and Tuesday. You don't have a homework assignment with you right now. I'm going to give you the homework assignment on Tuesday. So right now, you don't have anything else that you can be doing in this class other than read the project, and we'll discuss it more on Tuesday if you've got questions. All right, I'll see you then. Back in the computer lab on Tuesday.